Hi, this is Mr. Adams from Midwood High School, and this is a video on electrolytic cells. Electrolytic cells fall under the branch of electrochemistry, and in electrochemistry, once again, we said we have the voltaic cell where we have a spontaneous reaction, but in the electrolytic cell, the reaction is non-spontaneous. So since it's non-spontaneous, we need an outside influence to push or to drive the reaction, and that outside influence will be electricity from a battery. Some differences between the voltaic cell and electrolytic cell that jump up are the fact that the electrolytic cell has no salt bridge. Typically, it has one reaction chamber. The anode is positive and the cathode is negative. Well, the biggest difference is that it's non-spontaneous. All right. When we're doing half reactions for the electrolytic cell, we have to watch out for the Hun group 17 rule, which simply says if you're hydrogen, oxygen, or nitrogen, or in group 17, you would be diatomic. So we'll talk about that later. And in electrolytic cells, they're used in terms of metal purification and separation, and also something called electroplating, which we did a simple demonstration in class where we put copper onto the paper clip. Okay. As always, anode undergoes oxidation and the cathode undergoes reduction. This happens for both cells, the electrolytic cell and the voltaic cell. So let's just say, right, we have a KBr, molten KBr, and we want to separate it, right? We would put it inside this chamber, okay? Now, KBr in molten form, in liquid form, right, would give us K plus ions and Br minus ions. Okay, so we got K plus ions and Br minus ions. Now, what's going to happen? Now, notice once again, this guy right here, okay, is negative. This guy right here is positive. Our cathode is negative, right? And our anode is positive. So these charges are important because let's just say we have K plus, right? Positive K plus ions inside the chamber. Which electrode do you think it's going to move towards? Yes, it will move towards the electrode of opposite charge. Okay, so it will move towards the cathode. All right. So what happens at a cathode? As we said before, reduction or gain of electrons. So we will have K plus 1 gaining electrons, all right, and forming K0 of oxidation state 0. And as we said before in class, if you have an oxidation state of 0, you would be a solid. So you just separated out potassium metal right there. All right. And on the other hand, in terms of the other ion, if we have Br minus, okay, we see that it would move towards this positive electrode, which is the anode, and oxidation will take place. So we will have Br minus losing electrons, so the electrons will go on the product side, okay, going to Br0 plus an electron, right? But we have to watch out, once again, for this rule. Bromine is in group 17, and if it's by itself and neutral, it will be diatomic. Okay, so we have to say Br2. So we just simply balance our bromines first, our atoms. We've got 2 Brs and 2 Brs. We check if our charges are balanced. No, they're not. We got 2 times -1 right there. So that's -2, so we need 2 negatives on the product side, and that makes our equation balanced. So this reaction right here would be our reduction half reaction in the electrolytic cell, and this one would be our oxidation half reaction, and we get 2 useful products for our industry. Okay, we move on. In electroplating is a very, very nice, very, very simple process. We have our battery once again here, okay, and we have our 2 terminals, a negative terminal and a positive terminal, okay, And in the electroplating cell, all right, the electrolytic cells, in terms of electroplating, we need a solid, okay, form of the metal that we want to put onto the object. So, for example, this is our object. This key right here is our object we want to plate, right? We need a solid form of whatever metal we want to put on it. Now, in this case, it's silver, all right? So that guy, the solid form, will be at the anode, and oxidation will take place. All right, moving on, the object to be plated must be at the cathode, all right, where reduction will take place. Okay, so the key or the object is at the cathode. All right, and one last thing, we need an aqueous solution, all right, of the metal. So we need silver ions aqueous swimming around in here. All right, so there we go. All right, so what simply happens in terms of, let's look at the anode first. We know the anode undergoes oxidation, right, or loss of electrons. Okay, so you will simply have this solid metal, which we know if it's solid metal, it will be Ag0, right? Solid, right? So that guy will oxidize. So let's see what oxidizes. You'll simply have Ag0, right? Oxidizing, losing electrons. Okay, so it'll lose electrons and form Ag positive, right? Because remember, when we lose negative, we become more positive. Okay, in aqueous solution, and we will get a loss of 1 electron, and you're done. That's the oxidation half reaction that happens at the anode. And for the key, okay, which is at our cathode, okay, because it's undergoing red cat oxidation reduction, all right, we will have these Ag positives swimming around, right? It's gaining electrons, okay, they get in contact with the solution, so you will have Ag positive, right, aqueous, all right, and they are gaining electrons. They're coming around here from the anode to the cathode as always. Okay, reduction takes place, so an electron is gained, right, and it forms Ag0 solid. And that Ag0 solid, once again, doesn't go into outer space. It sticks to the key, covers it and plates it, and there you go. You just covered your key or whatever object in whatever metal you want to. Okay, so you've probably seen these baby shoes being covered with metal, or folks with their gold-plated jewelry. Okay, can be used in a wide variety of different things. Okay, guys, this is a brief video on the electrolytic cells. Okay, know your voltaic cells. We did that before. Know the differences between the voltaic cell and electrolytic cell. There's some important differences, and go from there. As always, hard work plus sacrifice equals success. Study, 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 and I'll see you guys soon.